Oldest quasar and supermassive black hole discovered in the distant universe. The most distant quasar and the earliest known supermassive black hole have been discovered, shedding light on how massive galaxies formed in the early universe. This discovery was revealed Tuesday at the 237th meeting of the American Astronomical Society, happening virtually due to the pandemic. The study has been accepted for publication in the astrophysical journal Letters. A quasar, or quasi-stellar object, is the compact region at the center of a galaxy that throws off enormous energy. They emit so much energy that quasars appear like stars through a telescope. Astronomers believe that the supermassive black holes at the centers of galaxies actually power quasars, acting like an engine. When gas falls into quasars at the centers of galaxies, they form disks of gas and dust that emit electromagnetic energy. This creates a brightness greater than entire galaxies. Jets shoot out of the quasar, pulsing with X-rays, and they are some of the hottest things in the entire universe. The jets blow gas and dust, which are essential to form stars, out of the galaxy. When a quasar forms, it signals the end of a galaxy's star-forming days. This quasar is 1,000 times more luminous than our Milky Way galaxy, and it's powered by the earliest known supermassive black hole. The light from this quasar took more than 13 billion years to reach Earth, and astronomers were able to observe it as the quasar appeared just 670 million years after the Big Bang. Its black hole engine weighs more than 1.6 billion times the mass of our Sun, making it twice as massive as that of the previous record holder. This is the earliest evidence of how a supermassive black hole is affecting the galaxy around it, said Fei Wang, lead study author and NASA Hubble Fellow at the University of Arizona, in a statement. From observations of less distant galaxies we know that this has to happen, but we have never seen it happening so early in the universe. The quasar has been dubbed J03131806 by the astronomers who discovered it. The most distant quasars are crucial for understanding how the earliest black holes formed and for understanding cosmic reionization, the last major phase transition of our universe, said Xiaohui Fan, study co-author and Regents Professor of Astronomy at the University of Arizona, in a statement. To picture the brightness of this highly energetic object, imagine our Sun, but 10 trillion times more luminous. Astronomers were surprised to discover this quasar was fully formed in such a short time, astronomically speaking, after the Big Bang. The presence of the massive black hole that powers it at this early point in the universe's timeline also challenges how astronomers understand black hole formation. For example, how did this black hole have time to form? Black holes created by the very first massive stars could not have grown this large in only a few hundred million years, Wang said. Typically, such massive black holes form when giant stars explode and collapse, forming black holes that grow in size. They can also form when a dense cluster of stars collapses. Both of these take time. This tells you that no matter what you do, the seed of this black hole must have formed by a different mechanism, Fan said. In this case, it's a mechanism that involves vast quantities of primordial, cold hydrogen gas directly collapsing into a seed black hole. The brightness of the quasar indicates that the black hole is gobbling up about 25 stars like our Sun each year, which powers an outflow of gas moving at 20% the speed of light. This loss of gas typically halts the birth of stars in a galaxy because that gas is a necessary ingredient in star formation. We think those supermassive black holes were the reason why many of the big galaxies stopped forming stars at some point, Fan said. Ultimately, the black hole will eventually run out of food, stunting its growth, Fan said. Multiple telescopes were used in the discovery and astronomers are eager to observe it more in the future. The galaxy that hosts the quasar is rapidly producing stars at a rate that is 200 times faster than the Milky Way. This would be a great target to investigate the formation of the earliest supermassive black holes, Wang said. We also hope to learn more about the effect of quasar outflows on their host galaxy, as well as to learn how the most massive galaxies formed in the early universe.